Hello guys, what's up? In this video, I will show you how to create a program that can detect colors and then calculate the weights of the colors in any image. Okay, this will be a pretty straightforward machine learning based computer vision project where we will use computer vision and Scikit-learn as our main modules. Okay, so we will be using two main modules in this color analysis project. They are Scikit-learn and OpenCV. Scikit-learn is a very popular module for machine learning and artificial intelligence, and OpenCV is a must-have computer vision module. Okay, computer vision, open means open source, CV means computer vision. So first thing first, we will introduce some new libraries like OpenCV, Scikit-learn, NumPy, Matplotlib, and collection. Our libraries will be okay. First OpenCV, NumPy, then Scikit-learn, then collections and Matplotlib for showing or displaying our pictures. Okay, so let's install them using pip. So this command will be like this: pip install OpenCV Python, then NumPy, then Scikit-learn, and then Matplotlib. Okay, so I already installed these libraries, so you can install it also by following this command. Okay, then we will, after the installation is completed, we can go ahead and import them. Okay, by the way, I will be using Jupyter Notebook Conca for this project. Okay, so let's import these libraries from collections, import counter. Okay, then from sklearn.cluster, import k-means, then from Matplotlib, import colors. Okay, import matplotlib.pyplot as plt. Okay, then we will import cv2 as cv, import numpy as np. Okay, now we will be reading an image. We need to choose an image to get started. Here is the image I will be using. If I show you, this is the sample.jpg. Okay, I will be using this image for this project. So reading an image. Okay, then I will be image equals cv dot imread a sample.jpg, then image equals cv.cbt color. Okay, I will be passing image and then cv dot color bgr to rgb. Okay, then dplot dot imshow image. Okay, so this is the image. We are using imread method by OpenCV to read the image, and then we are converting the color format from BGR to RGB, because by default OpenCV reads an image in BGR color format, but what we are seeing in this real or real life, this is in RGB format. Okay, RGB color format. Then we will use plot.imshow for showing this image. Okay, then we have to create some functions as functions for the pre-processing of our image. Okay, first function will be RGB to hex. Okay, so define RGB to hex underscore hex. Then we'll be passing RGB color as a parameter, then hex color as the hexadecimal color started with the hash sign. Okay, then for I in RGB color, then I equals int I. As I is in string format, then I will convert it into integer format. Okay, then x color plus equals, okay, then 0.02 x, then dot format, okay, dot format I for our image. Then we will return hex color. Okay, in this function we are converting a RGB color into a hex color format. This function will help at the end when visualizing the result for our analysis. Instead of having three different values like red, green and blue, we will have one output, which is the hexadecimal value. Okay, then we will be using another function which is called image preprocessing, or we can be say shortly define pre-image. Okay, that's the raw image. We'll be passing our raw image. Then our image will be modified, so I declare a variable like modified image equals cv dot resize. I will elaborate this function later on. Pass our raw image, then the size of our reshaping. Okay, then interpolation will be cv dot inter area. Okay, then modified image equals modified image dot reshape. Then we'll be calling modified image once again, modified image dot shape 0 into modified image dot shape 1. Okay, then we'll be passing 3, which will be return our modified image. Okay, this function basically does the pre-processing of the image. If you want to make any changes, we will have to do these changes in this function. Okay, we'll resize and reshape the image in this step. Here we will resize and here we do reshape. Okay, resize is kind of like optional, but reshaping is must. Okay, we'll see it in the following function. Then we will use another function for our main color analysis, so we'll be calling as define color analysis. Then we'll be passing a parameter like image. Then we'll be declaring a classifier like CLF for the short names, classifier k-means, be using k-means clustering. So K means clustering, and clusters. We will be passing n clusters parameter equals 6, and cluster parameters equals 6. Then color levels equals classifier classifier dot fit and transform, fit and transform our okay, sorry for inconvenience, fit and predict our image method. Okay, then will be center colors equals clf dot cluster centers. Okay, so we are using k means cluster the top colors. Inside the function we are passing the value how many cluster do you want to divide, how many clusters. Here is the line. Okay, after clustering we predict the color weights the most, meaning getting the most area on the image. Then we are calling, then we'll be calling counter function our. Okay, let's say counts equals counter color levels. Okay, color levels. Then ordered colors equals, will be used list comprehension method. Then center colors I for I in counts dot quiz. Okay, then will be hex colors equals, will be using again list comprehension method. Then we'll be passing RGB hex, basically this function RGB hex. Okay, RGB hex ordered colors. Then I for I in counts dot case. Okay, then dot case. Then we'll be use plot dot figure figure size will be define our figure size equals like 12 by 8. Okay, like 12 by 8. Then plot dot pie for displaying a pie chart. Counts dot values. Okay, then colors equals x colors. Let's equal x colors. Then we'll be save this image by calling plot dot save fig. We'll be calling this image name color analysis dot png. Okay, dot png. Then this will print x colors. Okay, so what we have done, we are calling the counter function. Counter creates a container to the elements as a dictionary keys, and their volume is stored as dictionary values. If you are not familiar with the dictionaries, then they store data in key and value pair. They are like function, and when you pass the key, you can find the value as written. Okay, then we are ordering the colors according to their keys. Like in this line, we are passing those colors in RGB underscore hex function so that we can get the hex values or hexadecimal values for this color. Okay, and lastly what we have done is the visualization part. I decided to go with a pie chart which will be helpful to understand the weight of each color in this whole image. After plotting the figure, I am also saving this like color analysis.png. Okay. This way we have a record of this color analysis report or results, and lastly I will also return the hex color values. Okay. Now we'll be calling modified image equals pre-processing of our image, prep image, then we'll be passing our image. In this image is basically indicates this image. Okay, basically this image will be converted in this line. So color analysis will be pass or modified image. Okay, modified image. We have the image defined earlier and assigned to the image variable. We will call the prep image function for the pre-processing of the file, and then we'll call our main function on color analysis for this modified image. Okay, let's wait and see what will be returned. Here this, okay, so congratulations, we have created a program that analyzes an image and returns the color report as a plot. Okay, here's something interesting to tell. We can define how many clusters we want to divide the colors into. Here I used n clusters equals 6. You can also use 5, 7 or 8, whatever. Okay, and this is it. Okay, so here comes the final result for this, and if we see this, we will have this color analysis.png, and this is our main sample file, and this is the color analysis report of this file. Okay, so thanks for watching. I think you enjoyed this video and learned something new today.